This is the presentations from Shenzhen SQ Biotech. The topic of the presentation is the missing part of the water treatment in aquaculture, free radicals. We all know that water has always been an important issue that everyone in the aquaculture industry would like to deal with. In this presentation, SQ Biotech is going to introduce the concept of free radicals, which has been testified in other scientific fields, but did not draw too much attention in aquaculture. And we're going to talk about where the free radicals come from and why they have something to do with this industry. This was the field research we did in Taiwan's local shrimp farming ponds in 2017. And surprisingly, we have found there were cross-infections of different diseases in a small area. The local fisheries farmers said the cross-infection of disease is actually quite common to them. But we start to wonder, theoretically, if it was the spread of the disease that caused the farm species sick and dead, then they should catch the same disease. But there were actually different diseases getting involved. So we propose that there might be some other reasons that cause the weakening of the organisms. So when the immune systems were getting weak, the species were prone to disease infections and led to the final death. Then what could cause the weakening of the organisms? The reasons might be the different breeds, the use of the drugs, and the effects of climate changes, and the pollutions from the environment. And we focus on the environmental issue and try to find out what are the toxic substances it would bring the harm to the farm species. We examine those data that most fishery farmers and researchers would traditionally see as the indicators in water quality and treatment, such as dissolved oxygens, ammonia, nitrite, oxidation reduction potential. And we have found that the farm species was still sick and dead, even though those indicators were normal. So we came to the reasoning that those indicators were not the real cause before we saw the death. There might be something else in the environment that were only small amounts, but also very destructive. That is free radicals. So what are the free radicals? Free radicals are the exciting and unstable status of the normal substance. They are generated when the normal substance gets stimulated by the environmental factors, such as air pollution, radiation, and UV rays. For example, in the chemical world, oxygen is the normal status, but they can get to the exciting status of a superoxide once they are stimulated. Actually, we have been using the products that contain free radicals in life for a long time. For example, the bleach can take away the stain on clothes. The hypochlorous acid can be used as the hand sanitizer as protection in the COVID-19 pandemic. But we also have to know that free radicals work as a double-edged sword. They can harm the enemies and also the users. Bleach can kill the bacteria, but also improper use can harm the users. So that's why we need gloves on when using these type of products. So what damages can free radicals make? Mainly, they can harm DNA, lipids, and protein. So too much exposure to the environment with a great deal of free radicals will lead to the death of the cells, genetic problems, and other immune system issues. The more free radicals in the environment, the more toxic and the damage they can make to the species in the environment. And where the free radicals are from? The free radicals come from the environmental stimulations, including the air pollution, radiation, smoke, UV rays, and microorganisms. According to the medical research, the free radicals in the bodies are the cause to the human cancers. So in other words, environmental free radicals cause cancers in environmental species. Now we have to think, what are the sources of the free radicals to the culture pumps in aquaculture industry? They come from the air pollution and the microorganisms in subsoil. The air pollution will generate free radicals, and the free radicals will get into the culture pumps when they attach to the dust in the air or fall into the pumps with the raindrops. The microorganisms will also generate a small amount of the free radicals to uptake other organisms in order to survive and compete. Because of the abuse of antibiotics by fisheries farmers, the microorganisms which don't get killed will mutate and become a stronger type of organisms. Those organisms will generate more free radicals to decompose antibiotics and make themselves resistant. Therefore, free radicals released from the air pollution and microorganisms will become toxic to the species, making them sick and even dead. When it comes to the air pollution, we often talk about PM 2.5. What is PM 2.5? PM 2.5 are the little tiny small particles which are the size smaller than 2.5 micrometers. They can be dust, raindrops, or even pollen. And these little tiny particles under the size of the PM 2.5 are basically invisible to the naked eyes. When the air quality is bad, we can usually see the skies turn gray and gloomy. That is because there are gray particles floating in the sky. But the size of the particles visible to the naked eyes needs to be at least 0.1 millimeters, which means these PM 2.5 particles have grown up at least 40 times to the gray floating particles, so they can become visible to the human naked eyes when the air quality is poor. So what makes PM 2.5 the tiny little particles grown up? Now we're going to talk about the toxicity of PM 2.5. It is the attached substance including bacteria, organic matters, and even heavy metals that increase the size of the PM 2.5 and make them toxic. When these PM 2.5 particles attach to organic matters, they will generate free radicals under the sunlight. This phenomenon is called the Quinoa redoxic cycle in the scientific community. The reaction is mainly to show that suspended particles can continuously produce free radicals when being exposed to the sunlight. So in other words, every tiny little PM 2.5 particles is a small free radical projection factory, and the projection of free radicals under the action of the sunlight is restless. Microorganisms will also generate free radicals based on self-protection mechanisms. Because free radicals release can help them decompose the toxic substance in the environment, so they can survive and compete with other organisms. So the purposes of microorganisms generating free radicals are survival and competition. The biological mechanism has been proved by Professor Colling. In his study in 2007, it shows that E. coli will generate hydrogen oxide under the work of antibiotics. In the following slides, we're going to introduce the nature and the features of free radicals to help us understand why they can make a difference, even just a small amount. At the end of the presentation, we will also show some field research results about what we have found. The normal substances are stable because they carry even galactons. But when they are stimulated by the environment and carry out the galactons, they will become unstable and highly active. And those substances carrying out galactons are what we call free radicals. Just imagine the physicist Dr. Bruce Banner in the Avengers movie had become the Incredible Hulk when he got the stimulations from the gamma bomb. And he changed from the normal status to the unstable one. He explained how the normal substances are influenced by the work of free radicals. Free radicals are in unstable status and have two features. The first one is chain reaction. The unstable free radicals will become stable and neutralized when they collide with another free radical. If the free radicals collide with normal monoculars, it will only pass on the free radicals to the monoculars, so the monoculars will carry out electrons, becoming another free radicals, and will finally be neutralized until they collide with each other. The neutralization of free radicals will lead to the change of the substance. When a normal substance is transformed into a free radical molecule, its structure and properties are greatly changed. When a free radical molecule is transformed back to the normal status, there is no way to return to the original substance. When the electrons transfer between each other, the structural changes of the matters are irreversible. So it will cause the death of the cells and decomposition of the matters. The reason why the chain reaction of free radicals will have a strong impact on the formed species is because in the process of neutralization, the normal molecules will become another forms of the molecules, leading to the death of the cells and decompose of the substance. The following diagram shows the work of free radicals transferring electrons to another molecules. It's somewhat like the bite of the zombies. Molecules that has become free radicals, just like the zombies, will continue to pursue the next victims until free radicals are neutralized. Due to the characteristic of chain reactions, free radicals will have a small amount of large-scale effects. In fact, the free radical reaction is part of the cycle of metabolism in nature. The second feature is called dynamic equilibrium. The amount of the free radicals generated is determined by the level of the pollution. Too much free radicals represents too much stimulations in the environment. The reductions or the neutralization of free radicals is determined by the probability of the particle collision. Environmental free radicals are the net of the value of generating and neutralizing free radicals per second. However, The free radicals are generated and neutralized every second, so the net value is actually constantly changed, which can be regarded as dynamic equilibrium. The production of free radicals depends on the amount of the environmental stimuli. The neutralization of free radicals comes from the collision probability of the particles. However, the neutralization doesn't change that much under the condition of high or low generation of free radicals. Therefore, to reduce the amount and the generation sources of free radicals is the best way to reduce the environmental free radicals, which will also provide healthier environments for the farm species. The molecules with unpaired electrons can be called free radicals. There are two types that are mostly discussed: reactive oxygen species and reactive nitrogen species. Among the species, hydroxyl radicals are both highly active and toxic. So in our research, the study focused on the statistic of hydroxyl radicals. Let's look at the data we collect from the field research in the local clam ponds. We have found that the amount of the free radicals was higher in the rainy days than those in the sunny days. Also, we didn't see any sickness or death of the farm clams until 2 to 3 days after the amount of the free radicals reached the peak. This research can show the amount of the environmental free radicals will increase as the particles fall into the ponds with the dust and the raindrops in the rainy days. The number will be higher if the air pollution is getting worse, and the toxic substance in the environment make the species vulnerable, so they start to fall ill and even dead. At the same time, it can also be found that the effects of the free radicals on the organisms is delayed. Free radicals cause damage to the immune system of the organism, and then the bacteria in the environment will cause the immune system compromised organism to get sick or even dead. Let's take another look at the case in the shrimp culture ponds, and it corresponds to the previous case. The data were higher in the rainy days, and the shrimp start to fall ill around 2 to 3 days after the amount of the free radicals were getting higher. And in the case of the aquarium, we can also see that two indicators were especially higher when those filtering equipment didn't get changed frequently. However, the other three indicators of free radicals are significantly lower when filtering equipment were changed much often. The aquaculture industry has always been eager to find out symbolic indicators in the water treatment, so the fisheries farmers can do something to stop the damage as precaution before things get worse. And according to our research, we have found that the environmental free radicals are an important indicator when the water quality gets worse. How to reduce the amount of the free radicals is definitely a critical part when the fishery farmers deal with the water treatment in aquaculture industry, so they can provide a better and more healthier environments for the farm species and increase the productions. In the following slides, it shows how we detect the amount of the free radicals. We designed a device called FRD, Free Radical Detector. The free radicals can produce fluorescence when only reacting with chemicals. The intensity of fluorescence can help us determine the concentration of free radicals with extremely high specificity and accuracy. So that means if the water we collect had stronger fluorescence, it had higher concentration of free radicals in the water. The FRD has the following benefits when dealing with the issue of the water treatment in aquaculture industry. It can help us judge the current water situation and help us to predict when to perform the water treatment when seeing the concentration of the free radicals goes up. Since the probiotic product has been widely used in aquaculture industry, it can also help fishery farmers adjust the use of the probiotics products in case too much probiotics will generate too much free radicals and cause damage to the environmental species. Once we can detect the amount of the free radicals, it can give us the information of the water quality and how well the water treatment goes. If there is a known issue, FRD can help us discover when to take precautionary measures before it's too late. Overall, the FRD can help the fishery farmers adjust the use of antibiotics and probiotics products in case those products bring too much free radicals to the environment and the species. And it can also detect the amount of the toxin and use it as an index to see how polluted the environment might be. Now we know that reduction and neutralization of the environmental free radicals are important. The lower the free radicals are, the healthier the environment will be to the aquaculture species. So SQ Biotech has our way to neutralize the free radicals. We designed a free radical neutralizer called Undine, which can generate free radicals by sunlight to decompose the toxin and neutralize free radicals in the environment. Undine has high biological adaptability, no harm, and it's easy to process. The following diagram shows how Undine generates the free radicals and neutralizes the free radicals from the microorganisms and environment. Since ingredients of Undine comes from herbs and has slow release of its free radicals, it has high biocompatibilities and will cause no harm to the environment, aquaculture species, and even humans. According to the characteristic of Undine, it can be used to maintain healthy environments by neutralizing free radicals, promote biological growth, and break down the toxic substance. At the end of the presentation, let's look at the field research about the use of Undine. There are two groups in the same size of the breeding area in the local fishery farming region in Taiwan. In the test group, from the harvest results of the clam ploy culture with milk fishes, we can see with the use of Undine, breeding time became shorter, the yield amount increased, and the survival rate was significantly improved. which shows that Dean has greatly reduced and neutralized the environmental free radicals, thus providing a healthier living environment for the farm species and boosting the harvest. Knowledge is power. For more information about free radicals and SQ Biotech, please go to our website. Thank you.